Hi there, I'm Scott Lowe with ActualTech Media, and thank you for joining us for this Spotlight Series video. I'm joined today by Edward Qin, who is the Chief Product Officer at Algoblu. Edward, thank you for being here today.
Hi, Scott. Thanks for having me.
So Algoblu is one company we haven't talked to before, and you are going to be talking about network element virtualization. But before we get into that, can you tell us a little bit about the company and sort of the big problem you're trying to solve?
Okay. Algoblu may looks unfamiliar to you guys because our company is the main business and operation conducted mainly in China. 3 years ago, we established our Canadian company, and also we start doing some R&D work in Canada. So right now we have well-established business in China, and also we expand our business to Southeast Asia. And right now we are in the progress to develop the Canadian and the US market right now.
Very good. And as you know, reviewing materials before we had our discussion, I see you have something called network element virtualization. I'm kind of intrigued. What does that mean?
Yeah, NEV stands for network element virtualization. That's the term represent our brand new technology. Its idea is a similar like what VM did for the PC server virtualizations. But what VMware did is they try to abstract and virtualize the underneath the PC server resource to make it as manning a virtual machine, but they operate just like a physical PC server. But we employ the same idea, but what we try to virtualize is to virtualize the underlying network fiber port. For example, the Ethernet port. Mm-hmm. We all know that the Ethernet port is kind of the shared medias. So no matter is a gigabit Ethernet or 10 gigabit, even 100 gigabit Ethernet, it's all big pipe. So all the applications go through a very big pipe, and you cannot prioritize your traffic and allocate the associate like the bandwidth to different applications, which create the problem for many of the carrier today. Their network cannot support the multi-tier service. Give you an example, like the airline business. So on the same aircraft, the client can actually choose from the economic class up to the first class, right? You pay different money, but then you have a different class of the service. But for carriers network for today, it's really hard to do this. They cannot meet your personalized requirement. Even you're willing to pay some premium, but you cannot. That due to today's network infrastructure constraint. What NEV try to resolve is we want to enable the carriers, the network, to support this we so-called multi-tier class of the service.
So this is a layer 2 service. It looks like, from if what I'm reading is accurate. Is that right?
Yeah, that's right.
So to get some of those classes of service that you talk about, I mean, with other technologies, you have to go up higher in the stack. You're able to do that at layer 2, which feels like there'd be a lot more efficiency as well. Is that correct?
Yes, because what it do is not resolved by software or by the algorithm. Basically, what we did is we develop a FPGA-based chip. So this chip actually implement the NEV functionality on this chip. So its idea is use this NEV chip, we can virtualize the fiber port, no matter is a 10 gig or is a gigabit Ethernet port. It can slice it into as many as 100,000. We call autonomic channels. So this autonomic channel is the smallest granularity this NEV can manage. So once you have this very basic block, and when you want to provision certain service, for example, you want to allocate 20 meg channel or we so-called service interface to your Netflix, these applications over your 100, your broadband access. So just take an example. You subscribe, for example, at home, I'm Rogers Cable's customer, and my broadband is 100. And then we use this NEV technology. We can slice a 20 meg service interface, just dedicate for your Netflix applications. And over the network, we can provision an end-to-end layer 2 20 meg circuit for you from your home to Netflix, the server. So in this way, we can guarantee your user experience.
So there's an edge device with your FPGA essentially installed in a business or a home.
Yes.
And I assume there has to be a like device on the other end. Is that correct?
Yes. At the customer side, no matter it's a residential home or it's some branch of the business, we will place CPE equipment. It's empowered by the NEV chip. And also on the network side for the PE, we also have the NEV device.
Okay. So it sounds like this is we talk about this as this is an ISP service, right? So there's nothing going to be in between the ISP and the customer, or is there? I mean, could this be something that I have in my, in my equipment here and the provider's multiple hops away?
Yeah. Actually, this one is there's a two way to deploy this. First, because Algoblu itself is an operator. We are a tier 2 operator. We have our own backbone, and we can access our customers, no matter it's a residential or business customer. Then we can providing this service based on our network. Another way is we can partner with the incumbent carrier. Like in China, we partner with China Mobile and China Unicom. And also here in Canada, we have some local carrier. We can deploy our solution in their network, so they can enable their end user to use this new technologies.
How is this different or better than like a quality of service or, something that's an existing network standard? What does this do that's better?
I think for today's every people familiar with a quality of service. This one is more like the feature comes with your router and the switch equipment, and they are all software based. So its quality is not guaranteed. It's just like use
best effort.
Yeah, not best effort. They have some different algorithm like fairness or some first come first serve or some others different algorithm, but they're all software based. So right. It really depends on what's your traffic pattern and what's the CPU load, and also depends on what's the application you are running and how many applications running over the shared medias. So it definitely is better than the best effort service, but it's not strictly guaranteed service. So right. Sometimes what they commit the rate they can give you. Normally, I think I saw some paper published by the CenturyLink. It probably has as much as 20% difference from what they can commit and compare with what they can really deliver. But with AEV, there's our difference is we have the data. It's less than I think less than 2%. Normally, you can for some not very small granularity, we can the difference if we guarantee the bandwidth we allocate to you, the difference is less than 1% sometimes. So it's a hardware-based, strictly guaranteed SLA and the QoS. So I think that's the difference.
And this is a bandwidth guarantee? Is that accurate?
Yes, bandwidth, and also you can manage the latency and the packet loss ratio jitter. We can also guarantee those parameters. Normally need to be specified in your SLA agreement.
Okay, and that you essentially you quote unquote own the whole pathway, so you can make those kind of guarantees.
Yes, that's true.
Okay, interesting. Is the application for this primarily residential, or is it primarily business, or is it a combination of both? I mean, are you going after big businesses that have distributed organizations, like especially work from home type scenarios where bandwidth is required, or who's the customer in this?
Right now, it targets both for the enterprise and also for the residential. For example, for the residential, the main application scenario is for the residential customers who want to play some like a streaming game, cloud game, and also they want to watch the high definition like HDR 4K video streaming. And then we require a dedicated bandwidth to get better experience. And also for the enterprise customer, for the business users, they normally use this kind of service to access the application hosted in the cloud, like some SaaS, for example, the WebEx. They prefer to directly access this application rather than over the internet. So that's some other scenarios. And also for some enterprise customers, the application scenario including the IoT, the Internet of the Thing, for example, the smart factory to on the production line, they use some remote controlled or monitor quality auditions process to just take picture from the product line and send back to the centralized quality control system. But they need to respond to the product line almost in the real-time fashions. So it have very strict network performance and quality assurance requirement. So that's all the scenario AEV can is a fit for those scenarios.
When we talk about this being deployed in the home or in businesses for specific services, does the broadband provider strictly have to also support it, or can you support it without them?
I think we can. Right now, we support over our network.
Okay, understood.
Yeah. So to work with the other carriers, this one need to be deployed in the network end to end.
Yeah, and that would make sense. That was a question I asked before, but I wanted to make sure that I wasn't missing something. So
yeah,
I appreciate that. Edward, if people want to learn more about the NEV and what you're doing, where can they go?
I think we appreciate the people show interest to have new technologies, and also we want to partner with those the different company. Like what we try to reach out right now is like the carrier who willing to partner with us to trial this new technology. We think AEV is an enabler for carrier, which can without significantly increase, upgrade, or change their existing infrastructure, so they can providing the multi-tier class of the service. So this is the one potential collaboration opportunities. And also we willing to work with some box vendor who build the CPU equipment for the broadband market, and also for the vendors who is building the providing edge equipment, the large networking box, and try to see if they can leverage our new technologies or the chip to build some new product and use this new product to serve the customers. And also we are also develop some local partners in US and in Canadian market.
Very good. And if people want to learn more about the partnerships or about the technology, they can go to algoblu.com, algoblu.com, correct?
Yes. Actually, we are revamping this website. We'll put more information on the website.
Very good. Edward, thank you very much for your time today.
Hey, thank you, Scott.
And as always, thank you to our audience for watching this Spotlight Series video.